Again, I'm Anna, and this is Chris, and we are with TWIL Design Labs. We want to thank you so much for considering our project this year. We are a Lincoln-based company building a bridge between physical aircraft, interior materials, and digital design tools. So our project is a continuation of the 25-26 year, and we were honored with the School of Computing Senior Design's Gold Award, and we thoroughly enjoyed our experience, process, and outcome with the team last year. So our project is for students who like the space where software, 3D graphics, and design and practical problem solving all meet. The goal is not just to make something pretty. Our goal is to help real aviation teams see, clean, separate, and apply real scan materials inside 3D aircraft interiors before work ever happens in the shop. By the end of this video, you should understand the real problem, the technology landscape, and the piece of the senior design that you guys can own.
So the problem is simple to say, but hard to solve well. Aircraft interiors are expensive, customized, and extremely visual. A customer does not just ask for generic brown wood or a generic cream leather. They care about grain, gloss, texture, scale, and how all of that feels inside the cabin. Right now, those decisions can be fragmented. Physical samples might be on one table, scan files in another system, CAD files in somewhere else, and renderings in a separate tool. What we want is a workflow where real scan materials and real aircraft interior geometry can come together in a way that is clean, separated into usable objects, and practical for designers and completion centers to work with.
So TWIL Design Labs is the part of our company focused on scanning and digital assets. We are investing in the ability to scan real-world materials at a level that can support design, visualization, and eventually production decisions. That might be a walnut burl, it might be stone, woven fabric, carbon fiber, leather, tile, or a specialty aviation finish. The exciting part for you guys is what happens after the capture. A scan by itself is valuable, but it becomes much more valuable when it can be turned into an organized asset, mapped to a clean object, and then reviewed in a 3D scene. That is where the software challenges, that's one of the software challenges that we're bringing you.
The core senior design challenge is a technical layer inside a much larger MRO workflow. This slide is specifically the student-owned piece, not the overall business process. Once an aircraft interior has been digitized, the geometry has to become usable. Sidewalls, window reveals, flooring, seats, bulkheads, galley, and trim need to be understood as separate objects. The mesh needs to be cleaned, and surfaces need to be ready for realistic material application. Students would help prototype the tools and workflow that make that possible. Their work becomes the digital engine that supports the MRO experience we will show on the next two slides.
Okay. So when we say MRO, that's another word for an aircraft completion center, a place where a private aircraft owner is going to bring their airplane in to have interior work done or mechanical work done, paint, all of those kind of things. So we're going to shift to their point of view. This is not a student task list by any stretch of the imagination. This is just what we want a completion center or aviation design team, what they need in a system to let them do once the cabin has been digitized. So they're going to load their cabin scan. They're going to select meaningful zones, work with the clean and separated cabin components, apply real scanned TWIL materials, and review options with the customer and project team. The value for the MRO can move from what if to a confident visual design decision before expensive products and production even begins. The senior design work is behind the scenes making those actions possible.
At the highest level, this is the MRO story we want the software to support. The aircraft or interior components arrive. The existing cabin and relevant materials are digitized. The team creates a usable digital cabin, defines the meaningful components, and applies real scan finish options. The MRO and customer can then review and compare these options together. Once the design direction is approved, the project can move toward production and installation with much more confidence. Senior design is not responsible for the entire MRO process. Their work powers the digital layer behind the middle of it. Mesh cleanup, object separation, asset organization, material application, and visualization. That MRO workflow gives us a clearer way to think about the technology stack. These are the tools that can power the digital layer behind it. Our current thinking is to keep Blender in the workflow because it is practical, flexible, and student accessible for cleanup and prototyping. Unreal is attractive for interactive review and feature visualization. Keyshot should be useful for polished still renderings, but we do not see it as the center of the senior design build. We are also interested in clean asset formats like OBJ, FBX, USD, and PBR texture maps that can represent scanned materials realistically. Python could be used for automation, naming, batching, or testing segmentation workflows. Infrastructure should start local and practical, with cloud options like AWS only, where they clearly solve a problem.
There are several possible build areas, and we would narrow down the final scope with you guys. One area is object separation, helping identify and isolate the meaningful parts of the cabin. Another is mesh cleanup, so creating a repeatable workflow for repairing, simplifying, naming, and exporting usable geometry. A third area is material applications, so mapping scanned TWIL materials that we will scan on our flatbed scanner in a way that preserves the scale, orientation, and believability. A fourth is a prototype reviewer or a demo scene where a user can select zones, swap out materials, and compare looks. So we do not need every possible feature. We just need to focus on a few. We just need a focused project that works and teaches us what to build next. So success for us is not a giant feature list. It's a working prototype that makes the future clear. By the final demo, we would love to see a repeatable cleanup and separation workflow. We would love to see at least one demo aircraft interior scene and 12 scanned materials applied to defined zones. And we'd also love the documentation so that we can continue building after the handoff. The best outcome is that someone can watch the demo and say, I understand where this workflow is going, and I can see how this would be valuable to real aviation teams.
There are also stretch ideas that can make the project even more exciting. Depending on the team, one is more interactive material swap experience inside a cabin scene. Another is AI-assisted segmentation, where the system suggests what parts of the model might be a sidewall, floor, seat, or trim. Another is an asset library or upload flow that makes it easier for future TWIL materials to enter the system. These are not required. The core demo matters first, but if the team moves quickly, these stretch ideas give students room to push into AI, graphics, user interface, or cloud architecture.
So why does this matter? It matters because it has real world consequences. For TWIL, it helps create a foundation for our future scan to render service. For aviation teams, it can help customers, designers, and completion centers make clearer decisions before expensive production work begins. For students, it's a portfolio-ready experience because it touches on 3D graphics, data structures, asset pipelines, user experience, automation, and maybe AI. There is also a stewardship angle. Better digital decisions can reduce wasted materials, reduce rework, and help teams build beautiful physical materials more intentionally. You would not be solving a fake classroom problem. In fact, you would be helping us build something that we genuinely need.
So choose this project if you want to build where software meets the physical world. This is for students who like visual systems, 3D data, messy real-world constraints, and the satisfaction of making something practical. We need curious students who can ask good questions, make technical choices, and help us turn scanned materials into usable digital tools.
We will bring the business problem, the industry context, the materials, and the mentorship. You bring your computing skills, your ideas, and your willingness to build something new. Thank you for considering TWIL Design Labs. We would love to work with the senior design team and see what we can create together.